All right. So these two concepts, angular speed and linear speed, are exactly why in the previous section I hit so hard on conversions. Because on both of these, you really don't need to know the formulas. What you do need to know is what you're trying to end up with in units. The units that you're trying to end up with tell you exactly how to solve the problem. But it is good to look at these two formulas. Angular speed is omega, which is that curvy W looking thing, equal to your central angle over in radians, central angle in radians, over the time interval. Whereas linear speed is equal to the radius times the arc length divided by the time interval. Now, it's good to know the difference, like logically, between these two. Angular speed is, and both of these are only referring to circular objects, so like wheels, Ferris wheels. They love to use angular speed is the speed at the center of your circular object, right? It's only caring about the basically the angle as you go around. So in other words, angular speed does not care about the radius because it doesn't matter how long the radius is, your speed at the center is not going to care about that radius. Whereas linear speed is the speed from the edge of your circular object. So, for instance, if I'm spinning around in my swivel chair, this my speed, because I'm sitting in the very center of my swivel chair, would be called my angular speed. Versus if I stuck my foot out and I said, "What's the speed of my toe?" That would be linear speed because my toe is like the edge of a circle created by my toe. So linear speed does care about the radius. And because it cares that radius, that's why this theta isn't termed the central angle anymore. It's termed arc length because it's speed going around a circle. So it matters what the arc length is. Versus here, it does not matter what the arc length is. It just matters how many radians you have. Now, what is the other only difference between the two you can see? What's the other difference? There's one more that this has that or that is different from angular speed to linear speed. Oh, God. What letter is new in linear speed that is not in angular speed besides besides the original omega v velocity? R. R. So, if you spend all your time solving for angular speed, all you do to find the linear speed is, oh my gosh, multiply it by r. So, linear speed equals angular speed times the radius. So, it's a little shortcut that you guys can memorize. The linear speed is just the angular speed times whatever the radius is. Okay, let's, like I was going to point out before, you don't really need to memorize these formulas. One, because we are virtual and you don't need to memorize anything, but also because your problem, what it tells you to end up with, will tell you exactly how to solve it. So in this example, it says propellers of a ship have a radius of 1.2 meters at full throttle The propellers turn at a rate of 135 revolutions per minute. What is the propeller speed in radians per second? So, first of all, someone tell me what a revolution is in math and 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 other science. Exactly. It's one time around your circle. That's one revolution. Now, it's very good to note how many radians are in one revolution. Just radians. Radians. 2 pi. 2 pi. Whereas in the next example, because your radius matters, how much is one revolution worth here? What do you have to add on? Because the radius, one time around the circle, the length. Yes, 2 pi r. Remember that circumference? 2 pi r. Okay, so back up here. What is the propeller speed in radians per second? This is key. This tells you exactly how to work the problem. We want our units to eventually end up being radians over seconds. So this is exactly why in the previous portion I hit so hard on conversion, because all that this is a great big conversion where we eventually want to end up with radians per second. Now we start with 135 revolutions per minute, per 1 minute. So I need to end up changing both of these. How or what is the easiest one to convert? What should I start with? Oh my gosh, yeah, super, super easy. I'm just doing one conversion fraction from minutes to seconds. Now, where should I put the minute? On top, because we want it to cancel with the other minute, right? So if the minute was in the denominator, our new minute needs to be in the numerator. And then how many seconds, because I'm trying to go to seconds, how many seconds are per 1 minute? Yes. Yes, you're right. You're right. Now, I heard someone call you Dario. Do you go by Dario? Yeah. Okay, sorry. 60 seconds. All right. So now I have my seconds like I want them, but how can I get radians? Oh, I'm sorry. Yeah, well, yes. So, but what you're doing, I still want to keep consistent with my, oh my God, 2 minutes? Oh boy, I'm sorry. So here, I want to do another conversion fraction. I want my revolutions to cancel. So I'm going to put one revolution at the bottom. How much or how many radians are in one revolution? Because I want to end up with radians. 2 pi. So then our last step is to check to see if I'm ending up with the units I want, radians over seconds. I am. So I did everything correctly. And then I just have to multiply. So I'm going to multiply 135 times 2 divided by 60, and you get 9 pi halves. Or they may ask for it in decimal form, which is 14.1 radians per second. Normally in word problems like this, they do want it in decimal form because it's easier to conceptualize the value when it's in decimal form than it is, unless you think in fractions. But most people think in. Okay, so now Um, like I was saying, we did all that work to find angular speed. All that you would really need to do on this next step, if I wanted to get linear speed, would be to multiply by the radius. That's the shortcut. But I do want to show you the full thing just so that we can get another example in. So here it wants us to do the same thing, but it wants us to instead find the speed of the tip of the propeller. So this is like my toe I was talking about. This is the tip of the propeller and it wants it in meters per second. So again, the unit tells us exactly where we should end up. I'm starting with the same thing, 135 revolutions per 1 minute. I know I want to end up with seconds, so I'm again going to do that 1 minute per 60 seconds, where my minutes cancel, leaving me with seconds. But then I know I want to end up with a meter. So the only thing in my whole problem dealing with meters is my radius of 1.2 meters. And so you ask yourself, how far around my circle in meters is one revolution for this problem? Yes, there are 2 pi radians, but we don't want the unit of radians. We want meters. So how far around is one revolution in this problem? Yes, 2 pi times 1.2, right? Our circumference formula that we have there. And that is in meters. So we check, do my units all cancel except for meters on top and seconds at the bottom? Why, yeah. And so you end up with, oh, really don't want to do it. Could someone give me the answer? I think it's 16 point something. Oh, 16. Could you give me two? I always like at least two decimal places. Is that right? I think something's off. Yeah, that's what I think it is. But I think, are you guys rounding right? Okay, maybe I will have to do it. Are you rounding right? Okay, 135 times 2. Now, because there's a decimal in your problem, don't even bother to keep it in terms of pi. Anytime there's a decimal, they immediately don't want you to have it in terms of pi. So you can just go ahead and multiply pi in. Yes, new. Yeah, 16.965. Which, I went in and I looked at people that are asking me. I'm going in and looking at, no, not 19, Miss Sunderland. I'm looking at their tests. And I even, so last class, I went over one student's test. And he's like, I swear I got them all right. I swear I got them all right. So he went in and looked. All except one, he had gotten, so of the four he got wrong, three of them he got completely wrong just because he rounded incorrectly. So at the very, very end, he did all of that work and then he just, oh my gosh, put 16.964 and got it all wrong. It's heartbreaking. Try to be careful. I did for him because he asked. If you know that you're getting most things wrong because of rounding, come to stay during async, ask to go over your test. We'll look at it, and if I see that it's just a rounding error, I'll give you partial points back. Wink, wink. Are there any questions about anything?